You know, when you grab your phone to stream a 4K video or send like a massive file, you probably picture your data just floating through the air.
Right.
We
Yeah.
call it the cloud, right? Like it's this weightless, invisible magic.
It feels completely intangible. I mean, we've basically trained ourselves to forget that the internet is actually incredibly heavy. It's deeply grounded in physical reality.
Exactly. You look behind the curtain and suddenly that invisible cloud is actually thousands of miles of highly engineered glass.
Yeah.
So, welcome to today's deep dive. We are looking at a really highly specific product page today from HDTV Supply.
Yeah, the Avenview FO-MMD-SC-SC-40 50125 Duplex fiber optic patch cable, which I know was a mouthful.
It really is a mouthful.
Okay.
Okay, so let's unpack this. Our mission today is to translate this seemingly endless string of technical jargon and acronyms from the spec sheet into a clear understanding of the hidden physical backbone that powers your digital world. Starting with the core specs. It says this is a 50125 multimode OM3 aqua cable. Now, I mean, I understand that multimode implies like a multi-lane highway for light, right? Letting multiple data streams travel simultaneously compared to a one-way simplex cable?
Yeah, exactly. And what's fascinating here is the sheer precision involved in that.
Right, because if I'm firing multiple lasers down the exact same microscopic glass tube at the exact same time...
Why don't they just crash into each other and scramble the
Yeah,
data?
exactly.
Well, that is exactly where that 50125 geometry comes in. Think of multimode kind of like throwing a handful of different colored bouncy balls down a really long hallway.
Okay, I'm with you.
The 50 is the 50-micron glass core where the light actually travels. And the 125 is the 125-micron cladding surrounding it.
Right.
That cladding acts like perfectly rubberized walls, keeping those specific light waves bouncing forward at distinct angles without ever interfering with each other.
Oh, wow, so the cladding is literally corralling the light. And the spec sheet mentions it's OM3 Aqua and optimized for VCSEL laser sources. What does that actually mean for the data itself?
So VCSEL stands for Vertical Cavity Surface Emitting Laser. It's a highly efficient, incredibly fast laser. And OM3 is a standard of glass specifically purified and manufactured to handle the intense speed of those exact VCSEL pulses. Because of that specific pairing, this cable can seamlessly support 10 gigabit applications across its entire 132-foot length.
That is wild. Okay, so we have this unimaginably thin, perfect glass highway transmitting gigabits of data, but the second that light hits the end of the cable, isn't there a massive risk of it just scattering?
Oh, absolutely.
Like, how do we actually get it into a server without losing half the data?
Well, that brings us right to the connectors.
Yeah.
Specifically, the SC to ST connectors on this cable. In a high-density environment, like a huge server room, you cannot afford a sloppy handoff.
I imagine trying to blindly twist one of those old ST connectors behind a crowded TV stand is a nightmare.
Oh, yeah. Totally.
So this SC push-pull snap-in design must be better, but, I mean, is a simple plastic snap-in really enough to keep a microscopic 50-micron core perfectly aligned?
Well, it's not just plastic, and that's the secret. Inside that molded housing is actually a 2.5 millimeter ceramic ferrule.
Wait, really? Why ceramic? Why not just use hard plastic or metal?
Because of heat. Glass expands and contracts with temperature changes. If they use plastic connectors in a server room running hot, the connection would warp, the glass would misalign, and your data drops.
Okay.
Ceramic handles temperature shifts almost identically to glass, which keeps the alignment flawless down to the micron.
Oh, so that thermal stability explains the next spec, right? The insertion loss of just 0.25 decibels?
Exactly. Insertion loss is basically just the light that spills or reflects backwards when two cables meet. Because the ceramic ferrule aligns the glass so perfectly, you only lose a quarter of a decibel. Almost 100% of the light safely crosses a gap.
That's incredible.
Yeah, and that precision guarantees the cable can survive 1,000 mating cycles, meaning you can plug it and unplug it 1,000 times without ruining the connection.
And building on that ruggedness, we have to look at who actually uses a 132-foot zip cord style cable like this. The stakes are pretty high.
They really are. This is built for demanding setups like military applications, telecom networks, wide area networks.
Right, and the spec sheet points out the OFNR jacket, which ensures compliance with really stringent building codes.
Yeah, it basically means the jacket is strictly flame retardant, so if a fire breaks out, it won't travel up the cable like a wick between floors.
Which brings us to the real value proposition here. At $189.27, this pre-terminated solution actively saves businesses a ton on installation labor costs. You don't need a highly paid specialist splicing microscopic glass together on a ladder. You just snap it in. Plus, it's backed by a 3-year warranty and free lifetime tech support.
It's essentially a rugged plug-and-play solution for infrastructure that usually requires a lot of delicate heavy lifting.
So, to wrap up this deep dive, the next time you have a seamless digital interaction, remember that it relies entirely on highly engineered physical glass threads and snap-in ceramic ferrules quietly doing the work behind the scenes.
The cloud is, quite literally, made of glass.
Which leaves us with this final thought for you to ponder. As our wireless demands and cloud networks continue to grow exponentially, what happens when the physical, finite reality of installing millions of these specialized glass cables becomes the invisible bottleneck to our digital future?